Good morning, students. Today we are going to learn about chapter number 10, vector. Vector carries n marks. Vectors the magnipan laiko. Vectors ida koina important definition ani yare. Scalar haiba maga, vector quantity haiba maga. First, define scalar quantity. A physical quantity having magnitude only is called a scalar. Habidi magnitude khatamang leba. Example na length, breadth, height se. Koina numeral number de loina express to way ko. Aduna siguma se kai kawe magnitude kawe ba. Aduna scalar habisida yauduse length, breadth, height, distance, time, mass, and speed, etc. Sigama quantities mayamam lere. Sigima mangsida physical quantities hai se kaino. Quantities sida koina measure to yadaba laiko. Those quantities which are measurable are called physical quantities. Akoina measure tawba yaba quantities singi manungda amuk magnitude leba duga direction leba na khaiduebako. Dugi vector hasina command define tore. A physical quantity having both magnitude and direction is called a vector. Habidi nangi physical quantity sida magi magnitude numeral de express tawba yaraba and mathangda magi direction oina leira agadi kai korani dugi quantity se vector koreko. Example Vector की example खरा हारगदी velocity, acceleration, weight, force, momentum, displacement, etc. सुमाइन तौरगा कोइन scalar quantity हाइबा मगा vector हाइबा खाइदोए scalar quantity हाइदि कइनो a physical quantity having both magnitude only is called scalar and the vector is a physical quantity having both magnitude and direction. Amana magnitude khatamang leiba amana magnitude ka kaiga leiba direction ga leiba ko. Duga sida koina distance habasina scalar diare. Displacement habasina kai diare. Vector diare ko. Maram kai gino hai tardi hausi yangase. Distance habidi kaino. Distance is the part followed by a moving body have ko. Sida point A sida point am lere. Point A sida ena moving body amaso move tawre. Sigi move tawra kana ma se kai de loigre. B de loigre ko. B de loiradi A dagina B bawgi marakta akoina man nangi lambi ama fangi. Lambi sigi onthoaba length se kai korani distance kawiko. Distance is the part followed by a moving body and the displacement. Displacement is the distance between the initial point and final position of a moving body have. Nangi initial ga nangi initial means starting point have niko. Terminal sina aroiba final position duneba. Ani sigi maraksta lairiba distance to kaina represent awe displacement kawe. Dudi mase nangi starting point dagi kadom na chatkani terminal point na chatkani ko magi always direction ama laini baduna distance haraga dekho na scalar de chinge displacement haraga dikai gi manung de chalani vector gi manung de challe ko. Next, representation of a vector ama kamaina represent tawdoino haiba koina first line L haibam lorasiko. Let us consider a line L. Line L hai tardi it can be extended to any length in any direction. Any direction and any length ta koina expand the way arni. And on this line L, fix any 2 points say A and the B. Then we get a line segment AB. We can associate two direction with this line segment AB. Line segment AB's direction ani pibaya A dagi B da chatpa ama B dagi kadom da chatpa ama A da chatpa ama ko. Duna sumain taraga koina ABC ki mathakta arrow diagram ama hap taragadi kai represent tawre vector ama represent tawre. Vector means a directed line segment is called a vector. Directed oigadaba nangi line se ko. Directed means magi direction se prescribe tawgadaba. A directed line segment se AB with an arrow over it represents a vector whose direction is from point A to the point B. A vector is represented by a small letter. Vector ama haibasa kaina represent tawragasue small letter amna represent tawrasue ko with an arrow over it. Aduga nangi a small letter dugi mathakta kai tapakani akoina arrow diagram se hapkani ba. AB vector is equal to kai haragasu yare A small letter A vector haragasu yare ko. Aduga nang na point ani da hainingagadi koina A B hara ani adug A B iba matamda magi direction se A dagi B da chatkani ko. Aduna ahanbagi A se starting point se kai kawi initial point kawi and the final position B is called the terminal point of the vector AB vector. Nangi line ama direction bu leraba kai kaurani vector kaurani ko. Next topic, characteristics of a vector. A vector has three characteristics. Number one, magnitude. magnitude haise kaino yengase ko koina line L sidagi koina AB have a vector form togre. Then AB vector means a directed line segment from point A to point B nebuko. Then in the vector AB vector, the length of the line segment AB is the magnitude of the vector AB and is denoted by right AB vector and enclosed within modular sign. Modular sign gi manung da thamgani. A dagina B bao se kyam sangi have a length se. The length of the line segment represents the magnitudes of the AB vector. Nangi length to tareko. Number 2, direction. The direction of AB vector is from point A to point B. AB vector have a kind sigi first point se koina kai korani initial point kawi ko. B sina kai kawi terminal point kawi. Initial point means starting point and B is called the final position. Aduna the direction of the AB vector is from A dagi kadom na chat po itare B de chat po itare ko. Number 3, support. The line L of which AB vector is a part of it. Nangi nasagi AB haiba vector sa kaidagi form tore hai taragadi line segment nangi line L haiba sidagi form tore ko. Aduna line L of which this AB vector is a part of it is called the support of AB. The AB vector segi support kaweba. Aduna characteristics of vector se kya leire ahum leire ko magnitude, direction and support haina segi mong de leire. Now let's define position vector of a point. Position vector se command define the way. Let O be a fixed point in space called the origin of reference and P be any point in space. Koina O haiba fixed point nam laurasi magi maming se kai kore origin of reference kore ko and P be any point in space such that this OP vector is equal to R vector. Then this vector R vector is called the position vector, in short PB of the point P. Position vector ama form tawge hai tardi O haibam laur. O sidagi kanada join to boigadaba P sida. P is any point in the space niko. Then we can form a vector by joining this point O and this point B and whose direction is origin to point B. Nangi vector se form tawo matam direction se origin dagi always point P do the chat kaniba. Dusigi OP vector se kaina represent hole this R vector na represent record. This R vector is called the position vector of the point P here. Then write the position vector of A, position vector of B. Haitaragadi position vector of A is represented by OA vector. Position vector of B is represented by OB vector. Position vector bu hairaba nangi initial point se always origin oiniba. Sumain taraga position vector of a point lere ko. See important definition. Now next topic is types of vectors. Hauze koina vector se kaino khange ko. Vector khange aduga vector se kamaina represent we have asisu khange. Vectors ki characteristic kya lesu khange ko. Types of vectors. Number 1 type, zero vector. A vector whose initial point and the terminal point coincide is called a zero vector or null vector, and it is denoted by O vector. O vector haisina kai represent with zero vector. Zero vector means initial point coincides with the terminal point. Nangi initial point se kariga coincide taraba terminal point ga haibadi it has no magnitude. Nangi magnitude amta layroiba magi diko. Nangi initial ga kai coincides tawgre nangi magnitude se zero ta doiba sida zero vector gidi nangi magnitude se zero oidini ko. Example A vector, B vector, etc. In A vector, initial point is A, terminal point is A. So in taraga A ga nangi A B smile leram tardi kay korani zero vector gawe ko. Number 2, unit vector. A vector whose magnitude is unity is called a unit vector. Nangi vector ama same miba nangi line segment dugi length sa unit kya waraba 1 hoy taragadi that vector is called unit vector gawe ko. A unit vector in the direction of a given vector A vector is denoted by A cap and is given by A cap is equal to A vector divided by magnitude of A. Let us consider any vector A vector, then A unit vector. Acting along this A vector is given by kainapire A cap is given by A vector divided by magnitude of A. If magnitude of A is of 3 units, nangi A vector sige magnitude sa nang 3 units so itardi A cap haibudidi length kya tabam to 1 tabam toktra. Then a vector should be divided by kaina divide tawrakani 3 na divide tawnidana aduna nangi magnitude sina a vectors ta divide taw tare kuna unit length puthokpa ngamne yadugi unit length to the ek tariba vector do kai korani a cap kawre. Next topic, co-initial vectors. Co-initial vectors, two or more vectors are said to be co-initial vectors if they have the same initial point. Nangi same initial point level vectors singse co-initial vectors kawi. Example, OA vector, OB vector, OC vectors are examples of co-initial vectors since they have the same initial point. Initial point means they are starting from the same point. Co-initial vectors ID kaino. Co-initial vectors are those vectors having the same initial point. Initial point chap manana leba vectors singse koina co-initial vectors kawi ko. Number 4, collinear vectors. Two or more vectors are said to be collinear if they are parallel to the same line, irrespective of their magnitudes and the direction. Nangon the vector ani natraga ani dagi henbase collinear kauni bakayorakanda if they are parallel to the same line. Line amaga parallel oragadi. Vector ani here there are two vectors, vector A and the vector B. These two vectors are parallel to the same line L, and so A vector is parallel to B vector. Then type number 5, equal vectors. Two vectors A and the B vector are said to be equal if they have the same magnitude and the same direction. Magnitude direction chap manana vector ani do kay korani equal vectors kawi ko, and is written is A vector equals to B vector. A ga B ga chap manana irani. Example, AB vector represents small letter A vector, CD vector represents B vector. If AB line segment is equal to line segment CD and they have same direction, this arrow diagram represents the direction of the A vector and B vectors. The period arrows in A gi vector gi direction, B gi vector gi direction pirini. Direction ani se chap manare ko. Ado itaragadi A vector ga kai ga manarani, B vector ga manarani. Number 6, negative of a vector. Let A vector be a given vector. A negative of A vector is a vector whose magnitude is the same as A vector but the direction is opposite to A. Negative of A vector haitaradi A vector ga magnitude chap manaba but direction is opposite to kanaga opposite oiba A vector go oiba ko, and it is denoted by minus of A. Example, staying as ko AB. This AB vector represents small letter A vector. AB ga length chap manaba but opposite to AB haitaragadi kai tare BA haiba vector se tare ko. Then BA vector represents negative of A. A vector and negative of A are opposite in direction. Opposite ta chatna niba. Amana left ta chatladi, amana right ta, amana north ta chatladi, amana south ta chatniba ko. Aduna therefore AB vector is equal to minus of BA vector. This A vector is to be represented by AB vector. So mana minter se kaino. If we intersense the initial and the terminal point, initial ga terminal ga intersense taw taragadi mamang da kay sign lakani minus sign am lakani. AB vector is equal to negative of BA vector raiba ko. So kuna types of vectors lore. Yeah, now let's come to exercise 10.1. Question number 3. Classify the following as scalar and the vector quantities. So kuna quantities kar pire ko. The scalar na kaino, vectors na kaino khalas. Number 1, time period. Number 2, distance. Number 3, force. Number 4, velocity. Number 5, work done. Number 1, the time period. Time period has a direction like the it is a scalar quantity. Number 2, distance. Distance is a scalar quantity. Number 3, force. Force the direction like aduna force is vector quantity. Velocity. Velocity sukayuegi. Velocity is an example of vector quantity. Velocity means rate of change of displacement. Number 5, work done is scalar quantity. Sumantaraga ko na scalar vector kandupangam. Let's mathangi topic se kaino addition of vectors. Addition of vectors sida koina law kya leire. Triangle law of vectors saibamaga parallelogram law of vectors saibam leire ko. Si karigino haitardi addition of vectors. vectors se kamaina add tawwi haiba law duni. Number 1, triangle law of vectors statement. If the two vectors are represented in magnitude and direction by the two sides of a triangle taken in order, then their sum is represented in magnitude and direction by the third side taken in reverse order haiba. Koina first sida moving body am laire ko A dagi B da chatle, B dagi kai da chatle, C da mok chatle ba. Adu magi final position ji C ni dana. Masagi moving body se A dagi direct kai ga chatpaga mane na khanbe C da chatpaga manadra. Then if this AB vector represents AB vector represents A vector and BC side represents B vector, then this sum A vector plus B vector is represented by the third side. Atopa side se sina represent rani baduna. If AB vector represents A vector, BC vector represents B vector, then their sum is represented by the third side of the triangle and which is taken in reverse order. Reverse order do oigadaba A dagi B da chatpa, B dagi C dagi A da lakpagi mahuta A dagi kadom na chatpa oigadaba, C da chatpa oigadaba ko. C sina nangi final position do oigani, A sina initial point oineba. And this law is called triangle law of vectors. Important ni ko. Next law, parallelogram law of vectors. Parallelogram law of vectors na kay hai, if the two vectors are represented in magnitude and direction by the two adjacents of a parallelogram, then their sum is represented by the diagonal which is co-initial with the given vector 7. If the two vectors A vector and B vector are represented by the two adjacent sides, here the two adjacent sides is AB vector and AD vector, then their sum A vector plus B vector is represented by the diagonal. Diagonal de ani like BD and AC, but it is the diagonal which is co-initial. Co-initial means having the same initial point. Initial point like diagonal haibadi A dagi B da chalaba A dagi D da chatpa haitaradi co-initial diagonal se AC se tare ko. The sum of A vector and B vector is to be represented by the diagonal AC. Example in the figure, here side AB vector represents A, AD vector represents B vector, but by the property of parallelogram, the opposite sides are parallel and equal like then AB vector na A represents the utaragati this DC vector represents A. If AD vector represents B vector, then this BC vector also represents B vector niko. A vector plus B vector is equal to AB vector plus AD neba. AB vector plus this AD vector is represented by BC vector. Then apply triangle law of vectors. Triangle law of vectors apply to tardi which is equal to AC vector tareka. Then we need to find B vector plus A vector. This B vector is represented by AD. A vector is represented by AB. AD vector plus this AB vector is represented by DC. DC na represent tareka. Now AD vector plus DC vector is equal to AC vector by applying triangle law of vectors in the triangle ACD. Hanbagi dun ABC de apply to handag na kay de apply to re ACD da ko aduna sina kay kawe triangle law of vectors ko. Parallelogram law of vectors main taraga addition of vectors sida law kya lere ani lere ko triangle law of vectors and parallelogram law of vectors. Last. Next topic is properties of vector addition. Vector addition ki properties. Property number 1, commutative property. For any two vectors A vector and B vector, A vector plus B vector is equal to B vector plus A. A ga B ga plus tabu sa B ga A ga plus tabu ga chap mane ko. First, let us consider a parallelogram ABCD, and this side AB represents A vector, this side AD represents B vector. Sitare ko. Then sagi parallelogram logi vectors ki matungina sigi AC vectors na kay represent away A vector plus B harasware B vector plus A harasware siyang asiko. B if BC AB vector represents A and the BC vector represents represent hole B vector silore ko. Now in the triangle A, B and C. Triangle ABC sigi manungda. Triangle ABC sigi manungda AC vector is equal to AB vector plus BC, which is equal to A vector plus B. Then in the triangle ACD, BC vectors is same as AD vector. DC vector is equal to AB vector. Chap manay ko. Now AC vector is equal to AD vector plus DC vector, which is equal to B vector plus A. By combining these two results, we have AB vector, A vector plus B vector is equal to B vector plus A. Habidi sigi AC chap manabanina. Left side manaragadi right side should be equal ni ko. And then this law is called commutative property. Next property, property number 2. For any three vectors A vector, B vector and C vector, sum of A vector and B vector and C is equal to sum of A vector and sum of B and C. Habidi vector ahum pibagi manungda A ga B ga hana sum puthoaga C da add tawbaga A ga B C gi sum duga add tawbaga chap maneba ko. This law is called associative law. Then A B C. Now let us represent this A vector, B vector and C vector by the three vectors PQ vector, QR vector and RS vector. This PQ, QR and the RS are the three sides of A kayo hele quadrilateral amagi three sides ni ko. Quadrilateral amahan na lor PQRS sign logo sige manungda PQ represents A vector, QR represents B vector and RS represents C vector. Isigi expression sayang say A vector plus B. A vector plus B vector is represented by QR vector by kaina parallel by triangle law of vectors. Triangle law gi matungin ako PQ plus QR is represented by PR vector. Now addition of sum of A vector and B vector and C vector is equal to kaitarane A vector plus B. A vector plus B is represented by this PR vector ko plus and this C vector is represented by C vector. Sidamu triangle law of vectors policy ko. Triangle law of vectors panbakanda PR vector plus RS is represented by PS vector. Next find B vector plus C. B C gyana samputo right side ki matungina B vector plus C. B vector and C vector is represented by QS vector. QS na phangi ko QS vector. A vector plus B vector plus C. A vector is represented by this side PQ vector and B vector plus C is represented by this QS vector. By applying triangle law of vectors, PQ vector plus QS vector is represented by the third side PS of the triangle PQS. This is a representer if the right sides are equal for these two equations. Sige equations ani is the right side ani sa chakman na taradi left side ani sa manabam to eko and therefore A vector plus B vector plus C is equal to A vector plus B vector plus C. Sige expression sa amana B ga C ga hana plus tawba amana A ga B ga hana plus tawba ko. This law is called associative property. Then vector addition ki properties sa ani laire number 1 commutative property and number 2 associative property. For today, let's end here.